Tuning the ignition map in steady state is basically a repeat of what we did on the fuel side. We want to go back to the lowest RPM and lowest load that we can achieve and hold the engine in the middle of the ignition cell. Now what we can do is gradually advance the ignition timing a couple of degrees at a time while carefully watching the torque output on the dyno. The aim is to advance the timing until the torque stops increasing. This is the MBT timing for this particular combination of load and RPM. It's easy to say, but when you're on the dyno, you'll see that the torque figure moves around quite a lot. This can make it hard to decide if the change in ignition advance has actually improved torque or not. A tip I use is to enter the new advance in the cell, but before I press enter to lock in the change, I watch the torque figure carefully. I then press enter, and I'm looking to see what the torque does immediately after the change was made. If you continue to increase the timing, you'll find that the torque peaks and then plateaus. If you continue advancing the timing further, the torque will actually start to drop off. What we want to do is set the timing at the point where the torque first peaks. We can then increase the load to the next load site and make the same changes. As we did with the fuel map, we can speed up the job by copying the value from the current site into the next cell. With the fuel map, we typically expect the engine's fuel demand to increase as RPM and load increase. The ignition map doesn't work the same way though. We can expect the ignition advance to decrease as we increase load, but increase as we raise RPM. To ensure safety, I won't just copy the ignition value to the next load cell. I'll also remove a couple of degrees of timing at the same time. This means we will likely still need to add a little advance to reach MBT timing. Once we've completed the first column of the ignition map, we can copy this across to the next RPM site. From here, it's just a case of repeating the tuning process throughout the ignition table. As with the fuel map, I recommend doing this up to about 2/3 of the engine RPM limit. From here, we'll just do as we did with the fuel table and copy the ignition values across the remainder of the map. Since the engine is much less sensitive to ignition than fuel, we don't really need to be too concerned with optimizing the ignition in the high RPM, low load areas of the map, since the car won't be driven there. All we want to do is check that the engine is safe from detonation. We can do this the same way we confirm the fuel numbers by briefly driving the engine through these higher RPM columns. So by the end of this module, you should understand what you're trying to achieve by setting the ignition and how to approach the job. By now, the engine should be thoroughly tuned throughout most of the map, and you will already have a result that is superior to what the majority of professional tuners provide. We're now ready to move on to the full power tuning.